Good afternoon. I hope you're having a great build today. My name is Sam George. I lead Azure IoT. I'm here today to talk about a bunch of great stuff, a bunch of things that we've been innovating on and been busy on, a lot of customers that are already benefiting from Azure and Azure IoT, a bunch of partners that are building out the ecosystem. The first thing that I'd like to do is talk about the broader concept in IoT. IoT enables something we call a digital feedback loop. And what a digital feedback loop is a way to connect companies to their customers, to their operations, to their products, to their employees. If you think about it, many companies, including Microsoft, have broken feedback loops where you don't have great visibility into what's happening across these four areas. So the first step that IoT enables is, number one, being able to collect signal from these. The second step is to be able to find insights from that signal, and then finally to be able to take informed action. The informed action that you take results in things like optimized operations, happier employees and more productive, better products, and a closer touch with your customers. These are some of the things that IoT enables. And this digital feedback loop, and we call it a loop because it's not a one-time pattern. It gets better and better and better over time. As you gain insights from one set of services, it produces ideas for the next set of services. IoT, when you step back, is actually one of the core ingredients, along with edge computing and AI and connectivity, that's enabling the digital transformation of every business on the planet. This is a profound industry shift that's happening, that's going from taking incumbents that have been around for sometimes hundreds of years and enabling digital natives to go in and disrupt them. And many of those incumbents are also learning how to use these new powerful tools to fend off the digital natives. Gartner estimates there'll be 20 billion IoT devices connected to solutions by 2020. There's a tremendous amount of data being generated, and much of the value is happening within an enterprise and between enterprises. About 70% of the value to be realized is in business-to-business scenarios in IoT. We announced 1 year ago that we are investing $5 billion in IoT over the next 4 years, so we get to spend some of that. We're making very good use of that. But it's a testament to the order of magnitude shift that we see IoT enabling, that we would invest this much into this new wave of computing. So if you look at our product profile and what we've built out over the last 4.5 years, it really starts with, at the very core, IoT support as well as edge computing support. And that goes everywhere from Azure Sphere to IoT Edge, to our device SDK, to Databox Edge, and many others. To our certification programs, where we have over 1,000 devices certified by 250 partners. And even now, to have Azure services themselves that are capable of escaping the cloud, containerizing themselves, and running right on IoT devices in our IoT Edge platform. On top of that, we have a set of rich Azure services for IoT. We have some services that are very IoT specific, like IoT Hub and the device provisioning service and digital twins. And we have many, many others that are part of an IoT solution that are critical for collecting data, for finding insights from it, from triggering business processes. All of these services you find in today's production IoT solutions. And then we haven't stopped there at the platform level. We've been going up and making IoT faster and faster. One of the things that we introduced last year was Azure IoT Central, which is the first SaaS offering from a leading cloud provider for IoT. We also have solution accelerators as well as reference architectures. So we're not just stopping at the platform, we're helping enable a rich ecosystem. And the other thing that we've been doing is investing in a set of priority verticals across manufacturing, automotive, smart energy, smart agriculture, retail, oil and gas, and many others. And for these, we work with partners in those networks or in those priority verticals and provide oftentimes accelerators built on top of our solutions and our services to make those industries go faster and to help them transform. And then recently we announced Azure Security Center for IoT, which provides a rich set of security offerings that covers everywhere from the cloud solutions to the IoT devices to the edge devices that are part of that solution, that proactively monitors, looks for issues, recommends remediations, and keeps you safe. So this is what we've been busy doing. And if you look a little closer at some of our edge offerings, I think we have the most comprehensive offerings for IoT and edge computing in the industry. Everywhere from Azure Sphere, which we're going to talk about in a second, that revolutionizes security at the microprocessor level, to our IoT device SDK that enables cross-platform, open-source, multi-language support across all of the important operating systems in IoT, to edge computing with Azure IoT Edge, to edge stacks and infrastructure with Databox Edge, and even Azure Stack, enabling Azure services themselves to run on-premises and even fully disconnected. And then, of course, all of that paired with Azure with more regions in the world than any other cloud makes us a pretty compelling offering across what Satya likes to call the intelligent edge and the intelligent cloud. We've seen amazing customer momentum with customers going into production and in production. Many of the new ones that you saw in the keynote this morning, for example, Starbucks and Kroger. These are solutions that are being powered by IoT and increasingly by edge computing and AI on the edge. And more importantly, if IoT is transforming every plant, every business on the planet, it's important to have a rich ecosystem because IoT, as I've said many times before, is not a winner-take-all market. If the world is going to be transformed by this, it requires a broad set of partners and ecosystems. And so we've been very busy with the developer ecosystem, with the partner ecosystem, across many, many, many different aspects of this to make it so that customers have what they need and partners have what they need to get a great scalable IoT solution. We've been busy in our team putting together a rich set of resources for developers, and I'd encourage you to check these out if you're not familiar with them. Both our IoT school, where we have topics and we do trainings on all the different aspects of the services and edge computing and IoT devices that we provide, as well as the IoT show with a new episode coming out every Monday where we do sort of a behind-the-scenes look as we bring new offerings to market. We talk about the motivations behind them, the best practices, the patterns and practices for how to use those services in an optimal way. One of the best parts about working on IoT is to watch how it transforms industries that have been around for a very long time. It enables breakthrough new capabilities for those industries, and I think this is a great example. It's a company in Australia that manages trains, and so they've put together a solution that connects their trains using IoT and AI, and I've got a quick video to show you that.
I've always wanted to work in areas that I'm really interested in, and leaving an environment that our children will want to live in is really important. Public transport is absolutely a game changer, and it will be the way of the future. I'm an engineer with Downer Rail. When I'm on the train, I feel proud that I work supporting the reliability of trains.
There's 340 million journeys made every year. We look after the Waratah fleet within Sydney to make sure the trains are operating effectively, safely. It's an extremely busy suburban rail network, so it's a huge responsibility that we have. We're providing services to our customers to make sure that passengers can get on a train every day, safely, reliably. The trains are always there, they're always clean, and the customers enjoy that journey to work. We're getting 30,000 signals from each train every 10 minutes. So essentially, these are trains with brains. And so turning that data into an insight, those insights, that's really the gold dust. We've built a platform with Microsoft called Train DNA. It's almost like having a blood pressure reading to tell us about the health of the train.
Train DNA is going to turn that information that we're collecting into something that we can use to improve reliability of trains.
We're using Microsoft AI to be more intelligent about how we maintain and how we detect faults. We can anticipate when our trains are going to fail in the future. We can anticipate how much maintenance we're going to do and how much downtime is needed for that maintenance.
We're trying to do that via different varieties of mediums in terms of tablet computers, phones, HoloLens, which helps overlay work instructions onto their normal environment. The potential of the Train DNA platform is immense, but it could be from any particular asset. So it could be a bus, a ferry, could even be a road service. So being a science fiction geek, that's the thing that excites me, because all those things that we thought were years away, we're now actually doing, and it's an incredible place to be. We've got some exciting young people, some smart people that are really driving this change in an industry which has been quite conservative, and I think that's the thing that really excites me and keeps me going.
So let's talk about some of the momentum that we're seeing, both across customers and across some of our technology areas, many of which there are talks all week on, and certainly in the IoT school and on the IoT show, lots of content online. So the first is Azure Sphere. This is something we announced last year, and Azure Sphere is a unique offering for microcontrollers, and what it really enables is a level of security that has not been present on microcontrollers before, that was typically only found in modern operating systems like Windows and Linux. And so it brings it to that, and it really works on three parts. The first is the hardware itself that we license and is part of our hardware ecosystem. The second is the Azure Sphere OS, which is a Linux microkernel that Microsoft develops, maintains, patches, and the Azure Sphere Security Service that monitors Azure Sphere deployments worldwide, watches for issues, and can alert customers and provide patches for new updates. And then, of course, Visual Studio tooling. And for those that haven't done any work programming a microprocessor, having Visual Studio tooling for that is pretty significant. And so we have some great tooling that's available. There's a lot of momentum with Azure Sphere. One of the most interesting ones is the Guardian pattern. So the demonstration that you saw in Satya's keynote this morning with Starbucks is taking advantage of this. And this is a really interesting pattern, because what it is you can take an existing device that didn't have defense in depth and security boundaries built in, but has a network port. And you can take an Azure Sphere device and plug it into it, and it can now serve as a secure interface that enables that device to be networked and to pull data off of it. We also have a set of hardware modules, and what those hardware modules are is tested subsystems that can be put into new systems on chips to make system-on-chip development much faster. You also see a set of offerings across Seed, Avnet, A-Link, and USI that are coming soon or available now. And then finally, one of the last things we're doing is Azure Sphere is actually a tri-core chip. So it has 3 sub-chips on it. One of those is a Cortex A7 that runs the Sphere OS. And then there's 2 M4s at least. And those are capable of running real-time libraries and operating systems. And so that's coming this month as well. The demo with Starbucks was really unique, because what it shows and what Starbucks is doing with Azure Sphere and with IoT Central and Pilot is to be able to connect to these devices on premises. Now, typically, these devices were being updated with USB devices or with USB sticks and someone rolling a truck and running around and updating them. And this allows Starbucks to manage all of these devices centrally and to update them and to really benefit from that digital feedback loop that I was talking about just a minute ago. There's also Azure IoT Edge, which is our edge computing platform. It is open source, it's cross-platform, and it's container-based. The reason why we made it container-based is that the theory of edge is to enable services to run where you need them, whether that means in the cloud or on device. And if they're running on device, to be able to remotely manage not just the device, but also each one of the workloads that's running in it. So this is the sort of basis of Azure IoT. It's also fully extensible, so you can run your own services and your own code in it. And it supports offline operations. And so you can deploy IoT Edge deployment to it. That'll start working. And then you can actually cut the cord, and it'll keep running. And it'll run indefinitely, which is pretty significant in many environments, such as remote installations. It has full Visual Studio support, and it even supports Azure DevOps and Jenkins for CI/CD support. So it's really been doing well. There's a ton of momentum here that we're seeing across customers like Chevron and Vulcan Steel. Our deployments have been increasing 40% month over month of IoT devices in production. And we have a broad certification program that's part of our Azure Certified for IoT program. Already there's been 50 certified IoT edge devices, and we're seeing great engagement across the community. So again, this is open source. It's up on GitHub under the MIT license. And so we're getting a lot of interest and a lot of pull requests. For example, we've had developers submit requests to pull requests to support additional operating systems, which we've taken. And so this is how we're improving IoT Edge along with the community. Now, a typical IoT Edge deployment looks like what you see here, which is you have a cloud solution with an IoT hub in it. It's connected to a device somewhere out in the physical world, and the device is running the Azure IoT Edge runtime. The workload is a set of containers that are interrelated to form a processing pipeline that's been delivered down remotely to that device. And what we've done and what we're doing now is we're introducing the public preview of another way to deploy an IoT Edge workload, and that is to deploy it to an on-premises Kubernetes cluster. Now, why would you do this? The reason why we're seeing more and more customers deploy this into scenarios that require high resiliency. So if a single device fails, the workload can keep operating. So the way this works is that you have a Kubernetes cluster that's already being managed on-prem, and then our IoT Edge runtime, along with the container-based workloads in the IoT Edge deployment, get deployed down to that Kubernetes cluster using Kubernetes infrastructure. And yet it's still managed centrally from your cloud solution, so I can update the containers within that deployment. It's a really interesting pattern that we've seen, and it's something that, frankly, customers drove us to. We saw a lot of customers wanting to deploy IoT Edge workloads into Kubernetes clusters on premises. And so that is now in public preview. Another thing that we're seeing in edge computing is that there's a high correlation between edge computing and AI. In a lot of ways, the other part of the theory of edge computing is that it's easier to take compute to where data is than to bring data to where compute is. And in many scenarios, especially where you've got video cameras, it's generating a tremendous amount of data. Now, a video camera with compute and AI really forms the ultimate sensor, because it can sense things that only humans can, and it's updatable, and so you can continually improve it. So here's an interesting example of where AI on the edge comes into play. So this is a distribution center, and you see lots of boxes that are being routed already down different conveyor belts. Now, if I want to use AI in this, as some of our customers do, to optimize these and to make sure that packages are going onto the right belt and that any damaged packages are caught very quickly, AI running out on the edge is a perfect solution to that problem. And so we're really thrilled to announce that we're partnering with both Lenovo and NVIDIA to bring some really sophisticated and high-scale AI processing capabilities right out to the edge. So the Lenovo gateway that you see here, as well as the Tesla T4 chip, it's actually this big. So it's relatively small. And what this thing can do is absolutely incredible. So let me show you that. So when I deploy this solution, what it looks like is I have the IoT Edge runtime running on this device, and I deploy a workload with 2 containers to it. One of those is doing business logic and communicating alerts back up to the cloud. The other is running AI over 16 simultaneous video feeds at 30 frames per second. Like, think about that. It's incredible. So this device winds up getting connected to 16. There's another slightly larger form factors that has 2 of these NVIDIA T4s that can handle 32 video cameras. And what does it look like? It looks like this. So this is a video of this device processing AI, looking for boxes on the wrong conveyor belt, and also looking for damaged boxes that are running over 16 simultaneous video feeds at 30 frames per second. That's pretty incredible. And that's one of the reasons why we focus so strongly on the hardware ecosystem, because there's a tremendous amount of partners out there that are doing amazing work, like both Lenovo and NVIDIA are. I'm thrilled to announce that this solution is coming this summer, and NVIDIA DeepStream is going to be available in our IoT Edge marketplace at the same time for that. In addition to being able to deploy Kubernetes on premises, there's a bunch of other things that we've been building into IoT Edge. We're adding support, and it's in public preview, for Linux ARM64. We're thrilled to announce that Windows IoT x64 support is now generally available for IoT Edge, and that means I can run and deploy containers, Docker-compatible containers, right on Windows IoT x64 running IoT Edge. We have extended offline support that's now generally available, so you can deploy an IoT Edge workload, cut the cord, and run it indefinitely. We have new provisioning capabilities that work with our device provisioning service, and new tooling and diagnostics that are available. So on demand, you can reach down to your IoT Edge device and pull telemetry feeds off the data that the containers are generating. Now, while it's possible and relatively easy at this point to build an IoT solution on top of our services directly, we've also been busy, as I mentioned in the beginning, building capabilities like Azure IoT Central, which enables you to, frankly, provision an IoT application in about 15 seconds, configure it in a matter of hours, and go to production the same day. What's interesting about this and why we're doing it is we've seen that many customers, and frankly, many partners, are looking for something that is much easier to use and that has all of the basics that you have to do when you build an IoT solution at scale, like worrying about high availability and disaster recovery, worrying about global availability, worrying about zero downtime. All of these things can be difficult to do yourself, and so that's what we've done with IoT Central. We've also been very busy since the general availability of it just last year. We've added multiple dashboard support, so you can have per-user dashboards now. We have new rule action targets, including logic apps, functions, webhooks, and Azure Monitor. We have an inline Microsoft Flow experience, so that as you are monitoring device data and you find an interesting pattern, you can have it automatically trigger a Microsoft Flow and connect to its over 220 different connectors, such as Teams and Slack and Salesforce and SAP and others. We have expanded continuous data export support, so you can have IoT Central automatically export to storage, to event hubs, to service bus. And we just added custom branding experiences, so it's really personalizable now. You can make IoT Central look like your own solution. It really disappears, and it looks like your own solution. We've added support for gateway devices, so to be able to maintain the parent-child relationship of devices behind intermediate gateways. And then we have another large feature set coming this fall that we're excited to announce. And we'll be talking about some of those preview features in our deep dive on IoT Central. Something else that we've had available for quite some time, but I always like to drive awareness of it, is that something that we see is that as a customer gets an IoT solution built, inevitably they start to wonder now, when I connect millions of devices to it, how is it going to perform? Am I going to find bottlenecks in my own application? Does my business process work integration hold up to that level of scale? And so oftentimes what we were seeing in early years is that they would then go spend a bunch of engineering resources building a scale testing service. And so last year, we introduced the Azure IoT Device Simulation Solution Accelerator. This gets provisioned into your Azure subscription, and you can scale to millions of devices. We support record and playback. We support randomization, and we also support programmatic simulation. So you can use JavaScript to simulate a device, and we'll actually multiplex that out through a cluster of virtual machines and simulate random interactions from devices. We have customers that are using this in production to make sure in their CI/CD pipeline that their new changes are going to stand up to the scale that their solution is already in. We have a lot of great features coming in Windows 10. And instead of talking about those myself, I thought it would be better to welcome up Rashmi, who leads Windows IoT, to talk about what all those features are. Rashmi.
Well, thank you very much, and good afternoon. I'm Rashmi Malviarchi. I'm the Group Program Manager for Windows IoT. and it's a real pleasure to be here with all of you today here at Build. So we think of Windows IoT as the best foundation for your intelligent edge devices. You can get devices to market quickly, thanks to the richness of the platform. You can get advanced security built right in, along with long-term support and security updates. And you get smart capabilities to enable a whole new generation of applications and services, harnessing the power of the intelligent cloud and the intelligent edge. We offer 3 editions of Windows IoT, which really enables you to build a wide variety of IoT and intelligent edge devices and solutions. To start, we've got Windows 10 IoT Core, which is really ideal for these smaller footprint devices that require maybe more power efficiency or need to meet a lower price point, while still providing that rich platform for audio and video processing, beautiful UI, touch and speech input, et cetera. Then we have Windows 10 IoT Enterprise, and this is really a lockdown, full edition of Windows 10 for fixed function devices. So it's ideal for powering industrial PC class hardware that you can use for controlling a robot, powering industrial automation, acting as a sensor gateway, working as an interactive kiosk. The list kind of goes on. And then finally, Windows Server IoT 2019 is the newest edition of the family, and it brings all the power of Windows Server to fixed function deployments. So if you need failover clusters or need to aggregate data from thousands of devices, you need 64 CPUs or 400 terabytes of storage locally, you use Server in that solution. And of course, across all of these different editions, we provide 10 years of long-term support with security updates, plus the manageability and control that you would expect from Windows OS. I want to take a minute to share an awesome solution from IDEX Corporation. It's a great example of Windows 10 IoT Core and Azure IoT together in action to solve a really important problem.
Been a paramedic 22 and a half years. Come in at 8 a.m. The next thing is making sure all of our gear's on the truck so we're ready to run calls. Any of the tools from radio communications to adequate working trucks, they need to be ready at a moment's notice.
IDEX Corporation is responsible for developing mission-critical applications. The platform is connected to the engine, and so we're monitoring check engine lights, ABS events, speed events, mileage and fuel, the amount of water that's being flown in real time. It's got to eventually go up to somewhere, right? And so whether you look at, do we have our own servers? Do we manage information ourselves? How do we handle security is a big thing.
Captain is built on Microsoft at the edge using a Windows IoT Core as the on-vehicle gateway, connecting all the on-vehicle sensors and collecting data for analysis and diagnostics through a set of Azure Cloud services.
You literally can pull your phone out and pull a mobile dashboard up and look to see what is going on, why did it happen. Information that you now get at your fingertips can help drive you to do your job better.
It's a great solution from IDEX, and it's great to see our technology used in that way. So we've added a lot to Windows IoT since I stood on the stage at Build last year. First, on the OS side, we shipped the 1809 release in the fall, which brings 10 years of long-term support and security-only fixes. We also launched Windows 10 IoT Core Services, which is a new offering that provides that same 10-year long-term support for Windows 10 IoT Core, and it gives you access to Device Update Center. Device Update Center is a service that we subscribe to that will put device builders in full control over the updates that go to their devices. That includes OS updates, updates to your own applications, firmware, drivers, et cetera. And of course, we released Windows Server IoT 2019, as I mentioned. For IoT Enterprise, we've made significant update to the popular Shell Launcher feature in our latest release. Shell Launcher puts you in control over how much or how little of the Windows experience you want in your device. You can now auto-launch Win32 or UWP apps. You can suppress Windows UX like the Start menu, Taskbar, Action Center, et cetera. You can monitor app lifecycle and connect that up to Azure IoT, configure auto restart, and even act as a custom shell to launch other applications from within your app. Then finally, we've updated our guides and tooling to help you bring your device to production more quickly. Getting into Edge Intelligence now. As Sam mentioned, we've got Azure IoT Edge at GA for Windows 10 IoT Enterprise x64. And that brings with it device access within containers, as well as GPU-accelerated WinML evaluation. IoT Edge support for IoT Core and Server IoT are in public preview now, and they'll hit GA soon. We also have the Azure IoT Device Agent for Windows. Now, this is an open-source agent that makes it significantly faster and easier for you to connect your device to Azure IoT and perform common manageability commands. So it wires up these manageability interfaces for you such that it's super easy to call them from Azure IoT up in the cloud. We've had this in public preview since the beginning of the year, and now we're excited to announce general availability of this as well. And finally, in this section, I'm very excited to announce general availability for the Robot Operating System, or ROS, support on Windows. ROS is a really mature, open source robotics framework that's used worldwide for both commercial and research applications. We've heard loud and clear from customers that they really want to be able to run ROS and leverage that capability on the platform that they've come to know and trust, which is Windows. And so we're thrilled to be bringing this to Windows IoT. Lastly, on the hardware side, we've expanded our silicon support for Windows IoT Core by adding NXP IMX6, 7, and 8M in public preview for Windows 10 IoT Core, plus the Qualcomm Snapdragon 850 support for Windows 10 IoT Enterprise. So that's about kind of what's been going on over the last little while. Now for a quick glance at what's coming up over the next few months. First up, we've heard from customers that some of them they still have a significant code base and investment in Windows CE, and they're really looking for help for how to modernize those solutions to come forward to the modern platform of Windows 10. We're working on a technology now to actually run their Windows CE apps in a Pico process on Windows 10 IoT, making it way easier for them to move forward and bring to move forward to a new solution and leverage the benefits of our modern platform while also leveraging their existing code investment. Next, you'll of course see, thank you, Doug. Next, you'll of course see us at GA on IoT Edge support for IoT Core and Server IoT. And in an upcoming Windows Insider release, we'll be offering a new minimal Windows container base that's actually specifically designed for ML workloads that gives you WinML acceleration along with Azure IoT Edge. Finally here, we'll get to general availability of our NXP silicon support for Windows 10 IoT Core, starting in June for the IMX6 Solo X. That open source BSP will be available directly from NXP, and they'll be providing support as well. BSPs for additional members of the IMX6 family, as well as IMX7 and IMX8 series, will follow. Now, I covered a lot in a very short amount of time at a very high level, so I really encourage all of you to check out the deeper session that's happening on Wednesday at 2 p.m. You'll get to see a bunch of demos, including a demo of machine learning using WinML, a demo of robotics on Windows using ROS, along with some awesome new tooling in VS Code, a demo of the Windows CE migration layer I mentioned, and much, much more. So don't miss that. And then lastly, we have a hands-on lab for you at the IoT booth on the expo floor, and it's your chance to get your hands dirty with the Intelligent Edge on Windows. Thank you all very, very much for your time, and I hope you enjoy the rest of your time here at Build. Thanks, Sam.
Thanks, Rashmi. That's great stuff. I wanted to spend part of the time we have together to talk about the road ahead. Something that we love to do is to work with our customers and partners to talk about directions that we're going, to get feedback early, and to have that shape what we build. So first, we recently acquired a company called ExpressLogic. ExpressLogic has a real-time operating system that can operate in as little as 16 kilobytes of memory. For context, Azure Sphere starts around in the low megabyte range, about 2 to 4. And so there's a tremendous amount of devices that are smaller than that. The other thing is that Azure Sphere, as I mentioned, has those 2 M4 chips that run real-time operating systems. So in the blog that announced this, we made it clear that we'll be providing a real-time operating system offering, both for Azure Sphere as well as connecting to IoT Edge. And then for some types of installations, we'll also enable that to connect directly through IoT Hub. And so expect more on that coming soon. If you're interested, we'll have private previews coming up. Something that really drives us is to accelerate IoT. We think with the digital transformation of every business on the planet, it's important that IoT has to be just as easy as previous waves of computing were. So if you look at how easy it's become to develop an IoT solution, if you started with infrastructure as a service and building everything yourself, the IoT platform has made it quite a bit easier to do that. And that's a total effort, not just to develop it, but also to operate it. IoT Central has dropped that as well, where you can now provision and go to production in the same day. But we're not done yet. There's a lot left to do. And I wanted to talk about what it looks like now and what it's about to look like. So the first thing that I'm going to do is I'm going to show a quick demo of Azure IoT Central. Now, I've already provisioned an IoT Central application, and I'm using our new personalization features to make it look different, to make it look more like my particular brand. And the scenario that I'm going to show is around a workplace safety one. So in this, I'm using Azure Maps here on IoT Central, and I've got no devices. And what I'm going to do is go add a new device template. And I'm going to pick a custom one. And I'm going to do an asset tracking scenario. And what I'm doing in IoT Central now is I'm going to tell IoT Central the data that's going to be coming in from the device. So I can pick telemetry, states, events. I'm going to pick telemetry and specify accelerometer and hit save. And now IoT Central knows to expect that. I can then set up settings that I'm going to synchronize with the device, properties that I'm going to read from it or I'm going to store in the cloud, commands that it's going to receive, and monitoring rules, as well as a per-device dashboard for the device. So for example, if I want to set a KPI tile, I'll just call this one, let's say if someone's running too fast, I'll call this the slow down alert. I hit save, and now a KPI shows up. So it's pretty easy to do. And then if I were to switch over, now I've specified how this works in IoT Central, and if I were to switch over to Visual Studio Code, and I'm writing, for example, in C code, then I would write my code to communicate via IoT Hub up to IoT Central and send telemetry and things like that. It's still a lot of code to write. The one thing to notice about this is that I have to get the device software and the cloud software to match exactly. And this is true whether you're building your own solution, your own custom solution, or whether you're using IoT Central. And what's really going on here is that there's a tight coupling between the software that exists out on devices and the IoT solutions in the cloud. And we've seen this tight coupling before, and it frankly slows things down. It creates fragility in these solutions. We saw this in the past. Windows had this before plug and play was invented, right? If you remember, you used to buy devices and you would have to install a program on Windows to have those devices work. Well, today it's much different. Today you plug in a peripheral and of course it just works. The way that was solved was with something called a capability model. And what a capability model is the ability to specify the class of device, what it did, things like that, and that was passed along when the device connected. And then Windows knew how to treat that device without ever having seen the software on it. This made it possible to develop the software in Windows and the software on the devices separately and independently. It also enabled certification programs so that if a device was plug and play ready with certain classes of devices like keyboards and mice and things like that, it meant that users knew that when they went and plugged that in, it would just work. Well, IoT really needs to benefit from this as well. It's really important to make IoT, frankly, accelerate. And so we're thrilled to announce a new innovation that we call IoT Plug and Play. And IoT Plug and Play definitely borrows some of those core ideas from Windows, but it's decidedly cross-platform, open source, and it's meant to support any operating system, any device on the planet. There's benefits to this. For example, for developers can now dramatically reduce the amount of time they spend writing code for the device and then making sure that it lines up with the software and the solution. Customers and partners can now benefit from a rich ecosystem of plug-and-play ready devices that they know are going to just work without writing any code in their solutions. Device providers can build a device once and have it used by thousands or millions of solutions without ever having seen the solution itself. It's also all built in open source like we do on devices and using open standards. So what is this magic and what are we doing? So the way this works at its core is it's a capability model that we call a device capability model. It's simply a JSON LD schema, and the way this works is that each device capability model can have one or more interface. And an interface is composed of telemetry that the device sends to the cloud, properties that it synchronizes or sends read-only, commands that it receives, and optional return values back to the cloud. Once you specify this in JSON LD, you can also have multiple interfaces. And the reason we support multiple interfaces is for grouping and reuse, so that you can reuse interfaces across solutions. And we expect over time, working with the industry and partners, that there'll be standard interfaces that emerge. And we'll do this in an open and collaborative way, of course. So what gets interesting is once you have a device capability model, and first, Visual Studio Code right now is being taught to be capable of generating these device capability models, so you can author those, and I'm going to show that to you in just a second. But it does something more. Once you have a device capability model, it can automatically generate software for the device built on top of the SDK. And what that software does is effectively stubs out all the plumbing that you need to communicate with solutions in an IoT plug-and-play compatible way. And all you have to do is simply feed data. So it basically builds a code skeleton for you. And all you have to do then is retrieve telemetry from the device and fill it out and return it in a function. And away you go. And the rest is handled for you. We're also updating our certification program to have an IoT plug-and-play category. And once you've built this plug-and-play software, we have services that can automatically interact with your plug-and-play software to ensure its certification. You can then list devices that are plug-and-play in our catalog. And what that means is that partner solutions that are IoT plug-and-play ready, as well as IoT Central, you can connect these devices and they will just work. Data will start flowing, all of the dashboards will be populated, and IoT goes much, much faster. And finally, we're teaching our device simulation service about IoT plug-and-play as well, so that once you've defined a device capability model, you can say, go simulate 1 million of these, sending random intervals, or go simulate 1 million of these, and I'm going to provide programmatic way that they're going to tune themselves or change at scale. So the best way to explain this is to show how simple this gets. So what I'm going to do is I'm going to go back to that same solution, the workplace safety. And what I'm going to be doing is connecting, this is a device by Compal, and it's actually already plug-and-play certified. And it's an asset, just a little GPS tracker. And what I'm going to show is connecting this to IoT Central when it's never seen it before. So this is what it looks like. So I come to IoT Central, and I've done the work. This device is now plug-and-play ready. And I turn it on, and we're going to talk about how it gets its network connection in a minute. And if you see the spinning icon in the middle, a new device just appeared. So now instead of having to configure IoT Central and specify all the different fields, they're just there. All the telemetry's been specified, the events, data's already flowing from the device, all without any human intervention. If I go into settings, I can see all the settings that I can synchronize on this device. For example, how often it's sampling, whether its tracking is enabled, what its low battery alert is. I see all the properties that are coming from the device, the firmware version, the manufacturer, the board part number, and things like that the device provides through its plug-and-play descriptor. And now when I go over to Visual Studio Code, this is what it looks like to edit a JSON LD device capability model. So see, we just pasted in here a descriptor called accelerometer, which is of type telemetry. Now what's interesting is after I have this, then Visual Studio Code now has a build compilation step that'll go and generate code in the language of choice, whether C, C#, Java, Node, Python. And when I open that up, you see these are the getters for reading that value. And all I have to do is read that value from the device and return it. And that's it. And the rest is handled for you. Now, when the device connects to IoT Central, it presents a URI or it presents the device capability model itself. And then IoT Central knows how to basically interpret everything that device is capable of and then just start using it. Well, thank you. We're very fond of this one. So now what that means is that the time and the total effort for building an IoT solution just got lower, whether you're building right on top of the IoT platform, which supports plug and play, or whether you're building on top of IoT Central. But we are not stopping there with IoT devices. We're making it work with these things too. So with IoT edge devices. So the way this works, so last year we introduced this Vision AI kit. And for the demo that I'm about to show you, what we did is we plug and play enabled this device. And we made it so that once it's connected, it's going to present not only its capabilities, but it's going to start streaming video up to IoT Central as well. Now, as I mentioned earlier when we were showing the Lenovo demo, a camera with compute running AI is the ultimate sensor because it can sense things only humans can. So in this scenario, what I'm going to show you is that workplace safety demo that is using this as a sensor. And what it's sensing is whether safety procedures are being followed. In this case, whether someone's wearing a hard hat in a restricted area. So this is what the experience looks like of connecting an IoT edge device. So now, if you watch new devices, it appears. And now when I go and look at all the devices that are there, I see this device. And I see AI streaming from it. I see video streaming from it with AI overlays. So this is using IoT Hub's device stream capability to stream video from the device. I can see all the safety concerns that have happened in a certain area. And if I go over to the new IoT Edge Preview tab, I can see the deployment, the IoT Edge deployment that's been deployed to this device. And because IoT Central has device management capabilities, I can update it. So if I get a new capability, I can go back to my dashboard, update it, and see that new AI capability running on this device operating. It's super cool stuff. It's, in effect, plug and play AI. Now, what's better is that as this device generates events, I can trigger a Microsoft Flow to handle that event. So for example, a Microsoft Flow supports Teams integration. And so I can integrate with Teams and send images of the safety concern where all the supervisors can collaborate in Teams. Now this works with all sorts of systems, of course, that Microsoft Flow supports, from SAP and Salesforce integration to Slack and more. But this is true end-to-end accelerated IoT and AI. And so we're super thrilled about that. And then if you go back, sure, you can clap. So now if I go back to that Lenovo example, what we'll be able to do then is host all of those video streams coming from the camera as well, right in a single solution. And when you click on one of them, you can even see an individual camera up close and all the alerts that it's been sending. So we think this is going to be a huge accelerator for IoT. This is going to be in public preview in just a few months. The plug-and-play language is now open source on GitHub, and we're looking for feedback on it as we finalize our public preview and bring this to market. Now, IoT plug-and-play is part of a larger ecosystem, and so it's really important to us to have broad industry support and to work with all of our hardware and solution providers and even connectivity providers, which I'll show you in a second. And so we're thrilled to announce this set of launch partners so far. We're still getting a lot more of these have been part of our private preview. Both device manufacturers that are certifying plug-and-play devices, as well as solution providers that are providing plug-and-play ready solutions for plug-and-play, IoT plug-and-play devices, including this device from STMicro that's been certified plug-and-play ready. And again, this one's already available on our catalog. You can buy it, you can download, you can take a look at the device capability model and start seeing how plug-and-play works today. We've gotten amazing feedback, and what's been clear is that this really hit a nerve in terms of solving a core problem in IoT and making things go much faster. And so we've gotten some great feedback from all of these partners about IoT. Now, if you remember, when I held up this device, this is a little wireless asset tracker, it doesn't have a fixed network connection, so how do things like this be plug and play? Well, the way these things become plug and play is through a second program that we're talking about today, which is our IoT plug and play connectivity partners. Now, there's a set of partners in the industry who provide, including telcos and overlay network providers, that provide network capabilities for IoT. And we already have a device provisioning service, and so what we're doing is an integration between the two of them. So this is how it works. Let's say you have 3 Azure IoT solutions, one in Europe, one in the US, and one in China. One of our first launch partners is Twilio. And what Twilio's done is they have a really interesting system called Twilio SIM with Trust on Board. And what that is a hardware root of trust with an X509 certificate to securely identify it. So these certificates are then baked into the devices. And if I go and buy these devices and then place them in different parts of the world, Twilio supports many networks worldwide. And so as I place them, the only thing these devices have right now is they have a homing beacon back to Twilio's network, and they know about our device SDK. So what happens is when they wake up, they will go rendezvous with the Twilio network. Twilio will then check to see whether one of these devices has been claimed and provisioned using the Azure IoT Hub Device Provisioning Service, which is our provisioning service for its scale. If it has, Twilio passes control over to it. The device provisioning service then registers those devices with the correct IoT hub that corresponds to the right solution. It then, through the Twilio relay, passes back the connection to that IoT hub back to the device. Then the device connects to that solution and goes through the plug-and-play workflow and becomes fully operational, fully plug-and-play without any human intervention. So that's another really exciting thing that we're up to. So clap for that one, too. Our launch connectivity partners to date, in addition to Twilio, include Ericsson, Cubic Telecom, as well as Arm Pelion. So we're very excited about the ecosystem that we hope this creates and that we're committed to creating for IoT plug and play, and to make all of these solutions go much, much faster, and to make developing IoT truly delightful. The last thing that I want to touch on is Azure Digital Twins. So we announced Azure Digital Twins late last year, and we're still busy working on it. Azure Digital Twins, for those that haven't heard, is really an expanded way that composes on top of our existing platform to provide the ability to model any physical environment, whether this conference center or a smart stadium or a smart building or an electric distribution grid, and then connect devices to that. It's a more natural way when there's a physical environment that you're trying to understand to do IoT. This really is what led us to Azure Digital Twins. So Azure Digital Twins is comprised today of 5 different areas. The first is a spatial intelligence graph, which is effectively a way of building an object model for any physical environment, and then relating all of the objects in it, whether it's smart stadiums with seats and rows and things like that, whether it's buildings with floors and rooms, whether it's distribution grids with substations and endpoints and meters, to be able to then, once you have that, to harness IoT devices to make that model come alive and to keep it always up to date. And then to process events, to be able to define events on it, to process it and handle those events in a serverless way, and then to be able to restrict parts of that digital twin. For example, not everyone should have access to every part of a stadium or a building or a distribution grid. And then finally, to provide rich integration on top of it, where you can egress out to existing data and analytics services so that you can use Azure Digital Twins to track the past and predict the future, which is what digital twins are really built for. And we're thrilled to introduce IoT Plug and Play as part of Azure Digital Twins as well. It's actually part of a much bigger initiative in Azure Digital Twins that we call the Digital Twin Definition Language, which is a way of defining all of the different entities in a digital twin. Devices is just one of those. And so Plug and Play will work seamlessly with digital twins as well. And then where all of this is going is we're building a well-composed stack where you have at the base level our platform that you can use directly, always, 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 and that you can be incredibly productive with. That you also have Azure Digital Twins that are built on top of that platform offering, that if you want to model a physical environment and build a custom IoT solution on top of it, that's a great way to do it. And then Azure IoT Central, as Azure Digital Twins becomes generally available, we will put Azure Digital Twins capabilities in IoT Central so you can use it there too. And so what this does is not only provides a well-layered and composable stack, all secured with Azure Security Center for IoT, but it gives you different entry points to choose from based on your skill set and based on the scenario that you're trying to create. I want to leave you with a video that shows Johnson Controls, one of our partners, building on top of Azure Digital Twins and the way that they're doing that.
More and more, customers want to digitally transform their buildings so they can optimize their spaces, reduce energy, engage occupants, and increase security. As a leader in the transformation of buildings, Johnson Controls is constantly innovating, guiding customers to a smarter future. Johnson Controls has partnered with Microsoft to bring the Digital Vault offering to market. Built on Azure IoT and IoT Edge services, Azure Digital Twins, Cosmos DB, and Azure AI services, the Johnson Controls Digital Vault centralizes the data of the built environment from OT and IT data sources. Everything inside or associated with the building can be ingested into the platform. Digital Vault enables various use cases such as connected converged security, predictive asset maintenance, asset and space optimization, and more. Once the data is ingested, an active digital twin is developed which behaves as a compute agent, capable of communicating with other twins to update, learn, and predict. No matter where a building might be in its life cycle, the Johnson Controls Digital Vault enables complete building digitization. Existing buildings can be digitized by capturing the geometry and layout of spaces and locating assets with human tagging or machine learning. For buildings that are under construction or in the design phase, the Digital Vault can centralize data from 3D building information models or BIMs, adding additional information such as weather and energy prices to create a virtual building capable of precise scenario simulations. When the building becomes operational, OT and IT data fuse to optimize comfort and operating costs. An example of these concepts is being executed in a recently announced project in which Johnson Controls and Microsoft were selected to bring Digital Vault and Azure to the new headquarters of BIA, a sustainability pioneer in the United Arab Emirates. With the vision to create an entirely AI-enabled space, Johnson Controls will work with Microsoft to outfit the building with Intelligent Edge and Intelligent Cloud Service to optimize energy and space, and help building occupants be more productive through the use of a virtual AI persona. Together, Johnson Controls and Microsoft are driving the digitization of smarter, safer, and more sustainable buildings and spaces. Let's pull the future forward together.
So it's a great example of the types of solutions that our partners are building on top of this platform that we're bringing to market. 4 years ago, I stood, it might have even been on this stage, but I stood and I showed a preview of IoT Hub working with a developer kit that wasn't even certified yet. I don't think we even had the certification program. Today we're talking about fully operational SaaS platform that's generally available, plug and play, IoT Edge, AI on the edge, and digital twins. And so it's amazing the progress that we've made, and I want to thank our developer community, our partners, for being such a great part of this and really making the journey worthwhile. So thank you all. We have some great talks this week, from Azure Sphere to digital twins. There's a really cool example where we're showing it integrated with HoloLens and the spatial anchoring service. We have a great talk on IoT Central, as well as how it works with plug and play in much more detail. We have Windows IoT that we're going to cover in depth, Azure Sphere, and IoT Edge and AI. I'd encourage you to check all these out or watch them online later where they'll be available. And if you like the session, please rate it. And if you don't, I'll see you later.